Given an architecture diagram of a hypothetical e-commerce website, let's build out a dependency graph. In our e-commerce website, we have a shopping cart service, a recommendation service, payment service, fraud detection service, and a user account service. And the databases that these services used are sometimes shared across multiple services. In this solution, the services are mapped out with their dependencies. Notice, it's important that we represent this as a directed graph, meaning that there are arrows that help us indicate whether a relationship is a dependent or dependency. You may have noticed that in the dependency graph that I built, the shopping cart service has 0 dependencies. While it has the least number of dependencies, it is also dependent on many other services, which could possibly be indicative of a complicated refactor. The user account service has the most dependencies with 3 services relying on it. Refactoring it first would be the most risky. Looking at our other services, the recommendation service, payment service, and fraud detection service all have 1 dependency. This is to illustrate that a dependency graph is one way to help us visualize and make an informed decision. Oftentimes, we have to use additional context to weigh what would make the most sense to refactor first. Perhaps there's a payment service that needs to be integrated with a library as soon as possible. In addition, the original system diagram included databases. Even though it's not captured in the dependency graph that I built, it's important to consider the technology, size, and complexity of these dependent databases. Even if a service has no dependencies, it may have a huge shared database that can make it difficult to refactor.